Welcome, everyone. Today we'll be sharing the deeper dive analysis from our 2018 SAS, R, or Python Flash survey. After performing our own analysis of tool preferences and how they vary based on a variety of factors, we decided to hand our data set over to an actual data scientist to see what other insights could be gleaned from the data. Howard Friedman, Chief Data Scientist, Professor, and friend of Burtch Works, will be sharing the results with you. Howard is Chief Data Scientist at DataMed Solutions, a global health economics and outcomes research company. He also teaches graduate-level data science and statistics courses at Columbia University. He has over 15 years' experience in data analytics, health economics, and research at Capital One, the United Nations, and Syngene LLC. And he's a longtime member of the Burtch Works network. All right, Howard, let's see what you found in our data set.
Well, thank you very much, Mary. It's a pleasure to be here. Before I get into the details, it's probably worth reminding everyone that this survey has been performed since 2014. Originally, the goal was to compare the use of SAS versus R, and then it was modified in 2016 to include Python because of the popular demand. Now, in this particular analysis, we also have to reflect on the fact that this isn't a random survey. There's a lot of response bias. It's based on people who are familiar with Burtch Works, and it leverages Burtch Works' proprietary database. As part of that, survey responses were linked over to Burtch Works' database, and we'll see how that analysis helps inform some of the work that we're doing. It's also worth reminding that the sample is strictly US-based. Now, one of the most important things to think about when we start talking about data sets is what information is available. In this particular case, the key question was, what is the tool preference? Where it was limited to SAS, R, or Python. But because of the links over to Burtch Works' database, we're able to find out more information about the individual's company, who they work for, the industries, location, where do they live, the number of years of work experience, what was their education, specifically the highest degree they've earned, as well as also understanding what were those degrees in. For example, were they in computer science or another specific area. There's also a very interesting field called predictive analytics professional versus data scientist. And this is a field that's created by Burtch Works itself, where they look at specific aspects of what the person is doing and use that to layer on this extra piece of information. Now, what about the data itself and the analysis? Well, I just want to start by telling people that this is really basic exploratory data analysis. So please don't look for any Gaussian mixed models, no convolutional neural networks, and none of the highly advanced mathematics that you might be expecting. We're really focused on exploratory data analysis in this particular piece of work. So with that said, we're going to dive right in. And by doing that, we want to first remember that the overall picture for this last year was split 1/3, 1/3, 1/3 roughly between R, Python, and SAS. With that in mind, though, the question becomes, what are critical factors that are driving or associated with the tool preference? And the first one is this quantitative work experience. How many years has someone been working? Now, Burtch Works is a recruiting firm. They don't ask the individual's age, but they do know, based on people's resumes, exactly how many years have they been working in an analytics or data science field, based on what they've listed in terms of careers as well as the years in which they finished their formal education. The reason why we start specifically talking about this years of quantitative work experience is because it turns out to be very critical in influencing what is the tool preference. Let me start by showing a graph here, which is the distribution of the years of work experience for our population. And our survey consisted of over 1,000 respondents, so it's actually fairly sizable. And what you can see is if we divide it into 5-year increments, you'd roughly see approximately equal groups. Now, this 5-year increments turns out to be quite useful as we dig further into this tool preference. And part of the reason why is that when we start doing some simple analytics, the first one being just building a classification and regression tree model with only one variable, the variable being years of experience and the outcome of interest being tool preference, it turns out that the most critical cut point where you would separate out your populations is right around 10 years. Visually, we can see this as well. Less than 10 years, there's a tendency towards Python and R. Greater than 10 years, these are more SAS users. Now, as we dig further into this, we can understand a little bit of why that might be true. And this concept is going to come up more in our conversation. SAS is generally not only used with more experienced users, but also for decades it really has been a dominant software amongst governments and major companies. This transition in terms of the tool preference as a function of experience likely reflects a number of factors, including what software was used during their education, what are the different projects that people are working on as a function of their experience, as well as an overall tendency towards more freeware and open source tools that we've seen over the last decade or so. So we start with this basic concept that we reflect on, which is the years of experience is very important, and those with less years of experience leaning towards Python and R, those with more years of experience leaning towards SAS. But now we dig into this question of company type. Now it's worth noting here that we have information about the name of the company the person works for, and we can use that to then map over to a list of the Fortune 500 companies and just assess the relationship between tool preference and whether or not someone's working for a large company. And in this case, I drew the line at Fortune 500 employees. When we do that, we again see a preference for SAS amongst people working for these Fortune 500 companies, larger companies, and those who are working for non-Fortune 500 companies, having a bit more of an even distribution. Remember, the overall population was split roughly one-third, one-third, one-third. Why this tendency may be so? Well, it could reflect the fact that SAS tends to sell its proprietary software more to governments and larger companies, and smaller companies may be more attuned to using some of the open source freeware solutions such as Python and R. Of course, this is a rich piece of data in that we have another important piece of information. For each degree that the individual has earned, we know what was the title on that degree. So did you have a bachelor's in mathematics? Did you have a master's in business economics? Did you have a PhD in engineering? That information can be used to try and also see if there's a relationship between what is the degree specialty and the tool preference. But before digging into that, the first question is, what does the distribution of the degree specialty look like? Now, in this particular case, to make the analysis a bit simpler, I did a mapping where I took that free text field of what the specialty was and then selected the one corresponding to the highest degree. So if the individual's highest degree was a PhD, I selected the text field from the PhD. If their highest degree was a master's, then it was from the master's, and a bachelor's would be from the bachelor's degree. And then I added a hierarchy on top of that with people who had their highest degree including the phrase data science. It was assigned to data science, statistics to statistics, and then working our way down. The purpose being so that people were assigned to one and only one group for this degree specialty. After doing that analysis, you can see the distribution over here on the right, and what you can see is, first, there's no specific degree that dominates the respondents to this survey. People have a vast breadth of different degrees with different specialties as their highest degree. That said, the most common degree was a statistics degree. And once again, because I was working with free text fields and I was selecting if you had statistics named in your degree, this would include people who had degrees in statistics or biostatistics or applied statistics or any field that included that phrase. At the same time, if you look all the way down at the bottom, you'll notice that only about 2% of our respondents have a formal degree with the title data science in it. Now that might surprise some people since this is a survey of people who are calling themselves data scientists, but that also may reflect a few things. First, it may reflect the fact that a degree in data science is a fairly recent phenomenon. You wouldn't have found this 10, 15, 20 years ago. Also, it reflects the clientele responding to the survey itself, as well as the fact that many people working in analytics fields have been rebranding themselves as data scientists over the last few years as this reflects changes in the marketplace. as well as changes in the required skill sets. Now that we understand a little bit about the distribution of these degree specialties, the key question becomes, what's the relationship between the degree specialty and the tool preference? Here we can see, ordered on the left, are preferences for Python. And so people with computer science degrees and data science degrees have the strongest preference for Python, followed by the engineering degrees. The extreme on the right are those who had stronger preferences for SAS, with R being distributed somewhere in the middle. So on the right side, you can see those with economics degrees, statistics degrees, and business administration or business degrees having strongest preferences for R. Now, what's driving those preferences? Well, it may reflect what tools were used in school. It may also reflect a little bit about that designation we talked earlier that Burtch Works does in terms of that PAP versus data scientist. So there's predictive analytic professionals versus data scientists, and that's a Burtch Works identified field. Well, 90% of the people who are in business, statistics, and economics were identified as PAPs. That's that right side of this distribution here, who are mostly SAS users. Meanwhile, less than 80% of those in engineering, less than 50% of those in computer science and data science areas were identified as being PAPs. That is, they were identified as being data scientists based on that Burtch Works designation. Well, we've seen that there's a very clear split associated with tool preference based on the degree, and now we want to look a little bit more at what are some of the factors that predicted tool preference. One of the first ways to look at this is just using univariate logistic regression models and just asking, well, what factors are most predictive? I also built CART models. Once again, the outcome of interest was the tool preference, and I'm just trying to figure out which factors have, in that case, the highest variable importance as measured. And what we saw is very consistent. That is, the strongest variable throughout both models, the logistic regression models and the CART models, was this years of experience. And the second one was this PAP data science indicator, followed by this degree specialty. And as we walk through this chart, we can see other factors that may or may not have been critically important. Now, we'll dig into this a bit more later, but it's important to recognize that years of experience in the PAP data science indicator, because they are the strongest variables, they also tended to account for a lot of the variation that might have been explained by some of those other variables down below. In order to test that, I built multinomial logistic regression models, specifically trying to predict the tool preference. Furthest to the left, I'm just showing what a random model would predict in terms of accuracy. And since this was a 1/3, 1/3, 1/3 split roughly, 34% would be the accuracy associated with just a random model. Now, as we start building univariate models on years of experience or PAP, we could move our accuracy up to 45%. Layering on a few more variables, we start to see that we're really capping off. After we've already included years of experience and degree specialty in the model, the incremental inclusion of other variables really doesn't increase the model performance all that much. And that's an important thing to keep in mind. Now, once again, we're going to see a little bit about how this analysis stratifies across years of experience versus other factors, but it continues to see this trend of experienced users preferring SAS, those with least experience preferring Python and R. Now, what I wanted to do was specifically ask the question of how do these factors interact? And to look at the interaction, I just did a very simple exploratory analysis. I took the subset of the population with 5 or less years of experience and then did crosstabs versus key factors. In this first one, I'm taking the people with less than 5 years experience and looking at that relationship versus the highest degree earned. And what we can see is that for those who had less than 5 years of experience, they all preferred either Python or R. Bachelor's degrees, vast majority preferred Python. PhDs, vast majority preferred Python. And R and Python both being substantially popular amongst those with master's degrees. SAS by far being a tool that was not used as much amongst those who have less than 5 years of experience. Now we can contrast that with those who have 16 or more years of experience. Regardless of what degree you have, those with that substantial amount of experience preferred SAS, or in the last bucket, the PhDs, it's relatively even. But we see, again, a strong tendency across all degrees for those with more experience to prefer SAS. Now what about region? Well, region again shows a similar correspondence. If we select the people who have less than 5 years experience, SAS is by far the tool that is not used. It really is weighed between Python and R, irrespective of which region we're talking about. While on the other hand, when we look at those who have the most experience, we see that outside of the West Coast, SAS is really the most popular choice. Now, the interaction with the West Coast may refer to some other factors, such as maybe an interaction with industry or some other variable that's driving that preference. Now, another factor that we can look at is, once again, selecting those who had less than 5 years experience and asking, well, what industry are they in? And when we take those with less than 5 years of experience, regardless of industry, they are least likely to prefer SAS, with most preferring Python, a few preferring R. But once again, we see this consistent pattern of the experience really driving a lot of the ability to predict what is the tool preference. Well, I think you know how this works. If I say now to look at those with 16 or more years of experience, it's a pretty safe bet that SAS is going to be the preferred tool. And across all industries, we see SAS is coming out as the most preferred tool. So once again, a very consistent result, and I think this makes sense for those who understand a little bit about what might be driving those factors. And we're going to have a last slide on that. But as we reached back to the key takeaways, it's worth reminding ourselves of what we observed. We took a data set that was based on an observational study. We did a survey. It was mapped over to the Burtch Works database. The populations themselves are not random samples, but they are those who responded to the survey. With those factors in mind, we definitely saw that the years of experience and the degree specialty were critical variables in predicting what was the tool preference. Another observation was that this designation that Burtch Works creates, this PAP versus data science designation, is a very strong predictor. And it's something that reflects a little bit more about what's probably driving the actual tool preference itself. Because a lot of what we're doing is here in this analysis is trying to infer, doing some exploratory data analysis, of what's really the factors driving it. Which brings us really to this last point. Region, industry, and highest degree had minimal impact after controlling for years of experience. That years of experience is so critical that so many of those other factors really aren't 100% critical. They're interesting to note and maybe play some secondary role, but they're not absolutely critical. The key question here has always been, what's driving the tool preference? And it's an interesting question, one that I think about a lot because I personally work in all three tools. And I've worked in two of them for decades at this point. So what drives the tool preference, or in my particular case, my choice of tool? Well, it depends a little bit on, first, what exactly is the scope of the project? Depending on what is the data source, the volume, the variety, the velocity, the quality, I might pick one tool versus another. The other question is the application. What exactly is the work product going to be used for? Am I creating a model that is then going to be picked up by someone else and then used in a real-world application? Or am I responsible for creating that real-world application myself? So the scope of the project is very important in figuring out what is the tool preference. Another key question relates to training. So what software was part of the training? If you only used one piece of software throughout your education, that's probably the tool that you're going to prefer. Also, have you had to modify your preferences over time based on the market or requirements from your employer or other factors? And then lastly, after we've looked at job function, the data, the output, who's responsible for the training, one last thing to keep in mind is budget. And this came up in our conversation about those Fortune 500 companies. If you're working in an organization which simply can't afford to pay for proprietary software, then there's really going to be an encouragement to use those who have open source and freeware as opposed to proprietary software, unless you can make the business case otherwise. Well, that's really been all the analysis for now. It's a wonderful database, and I want to hand it back over to the team at Burtch Works.
Thank you very much for digging into that analysis for us, Howard. For those of you who aren't familiar with us here at Burtch Works, we're an executive recruiting firm specializing in quantitative fields like analytics, data science, and marketing research. We're the leading resource for insights about the hiring market, and we produce 3 comprehensive salary studies every year for our main specialty areas. These reports each contain 30+ pages of data and can be downloaded for free at burtchworks.com/study. If you're looking to browse for new opportunities, you can check out our niche job board, which is trafficked by thousands of quantitative professionals in a variety of fields. And if you're interested in more insights about the analytics and data science hiring market like the ones presented today, check out burtchworks.com/blog, where we post periodic updates with hiring market insights and analysis, including flash surveys on hiring demand, what motivates analytics and data science professionals to change jobs, and machine learning usage. You can also follow Burtch Works across our social media channels to stay updated on our latest research. Our YouTube channel has videos on salary research, career development, and much more, all tailored specifically for analytics professionals and data scientists. And if you'd like to see if we have roles that are fit for your experience or to inquire about our wide range of recruiting and sourcing services, send us an email at info@burtchworks.com to start the process. Thank you all for watching and have a great day.